Hello, welcome to video 1 of lesson 5.5 for Algebra 2. Today we're going to apply the remainder and factor theorems. Today your objective eventually is to use theorems to factor polynomials, but we have a couple of other skills to learn along the way. One of which is dividing polynomials using polynomial long division. One way to divide polynomials is by using polynomial long division. And it is pretty much the same algorithm that you use when you do just regular long division, but you probably just don't think about it quite so much. It's probably a little more automatic than what it will be when we're doing polynomials. Okay, for our first example, we're going to divide f of x equals 3x to the fourth minus 5x cubed plus 4x minus 6 by x squared minus 3x plus 5. All right, so your solution is going to be to write the polynomial division in the same format you use when dividing numbers. Include a 0 as a coefficient of the x squared in the dividend, because notice it's missing. We go from minus 5x cubed to plus 4x, and we need to have a spot for x squared. So we're going to insert a plus 0x squared. At each stage, divide the term with the highest power and what is left of the dividend by the first term of the divisor. This gives the next term of the quotient. And this is much more easily understood by an example. So let's actually get into this. So here's using our traditional division notation. We've got 3x to the fourth minus 5x cubed plus 0x squared plus 4x minus 6 in the little division house. And then we're going to divide it by x squared minus 3x plus 5. So that's on the outside. So we just pay attention to the first term inside the house and the first term outside the house. And we're going to put the quotient up at the top. All right. The first value that we get for our quotient is 3x squared, and we get that by taking that 3x to the fourth and dividing it by x squared. Remember, we just look at those first terms, those leading terms in the dividend and the divisor. Okay, and so when we do 3x to the fourth divided by x squared, we get 3x squared. So we write that on top because that's where our quotient goes, and this is the first term in our quotient. Now, once you do that, you're going to take the 3x squared and you're going to multiply it through the divisor. You're going to distribute it across x squared minus 3x plus 5. And you're going to write it below. So 3x squared times x squared gives us 3x to the fourth. 3x squared times negative 3x is negative 9x cubed, and 3x squared times 5 is 15x squared. So we multiply and we put it down here. Now, I don't know if you remember from number long division, what you do now is you take this little product here and you subtract it from the original dividend. So we're going to subtract all three of these terms from the like terms up here. Okay. So let's see. 3x to the fourth minus 3x to the fourth is 0. So that's what we wanted. That's our goal, is to zero out this first term. Negative 5x cubed minus negative 9x cubed is going to be the same thing as adding 9x cubed. So negative 5 plus 9 is 4x cubed. 0x squared minus 15x squared gives us negative 15x squared. And then you bring down the next term, so plus 4x. Then we repeat this process. We're going to look at the leading term here, the 4x cubed, and we're going to divide that by x squared, and that's going to give us our next term in our quotient. Okay, so we do 4x cubed divided by x squared is 4x, and so we're going to write that up here, and then we're going to multiply it by x squared minus 3x plus 5. Okay, so we've got a plus 4x, we wrote that, and now we're going to multiply the divisor by the plus 4x. So 4x times x squared gives us 4x cubed. 4x times negative 3x gives us negative 12x squared. And 4x times 5 gives us plus 20x. All right, so after we multiply, okay, that's what we did here, we subtract. And then the last thing we'll do is bring down the next term, and then we'll keep working from there. So 4x cubed minus 4x cubed is going to give us 0x cubed, which is what we wanted to do. Negative 15x squared minus negative 12x squared, that's the same thing as plus 12x squared, so that gives us negative 3x squared. 4x minus 20x gives us negative 16x, and then we bring down the minus 6. Okay, so now we're going to repeat the same process we've been doing, but we're going to take the negative 3x squared and we're going to divide it by the x squared, and that'll give us the next term to put into our quotient. Okay, so negative 3x squared divided by x squared is negative 3. So we're going to write negative 3 right here and multiply the divisor by negative 3. So there's our negative 3. So now let's multiply. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 3x gives us plus 9x. Negative 3 times 5 gives us negative 15. Okay, so after we multiply, we subtract. So negative 3x squared minus negative 3x squared, that's negative 3x squared plus 3x squared, that zeroes out the x squareds. Negative 16x minus 9x gives us negative 25x. Negative 6 minus negative 15 is the same as negative 6 plus 15, and so that gives us plus 9. Now, we are down to the remainder. How do we know this is a remainder and we don't keep going? Well, if you tried to keep going, here's the thing. You've got a plain x here and you've got an x squared there. You're going to end up with some weird kind of fraction kind of thing. And so you know you're done. The quick way to know you're done is whenever the degree of what you're left with is less than the degree of the divisor. So here, we're left with negative 25x plus 9. So a plain x has a degree of 1. Oops. Well, goodness. Whenever you are left with a degree of 1 and you had an x squared, then you can't go any further. If we had started off with an x cubed and we had an x squared down here, we couldn't go any further. If we started off with x to the fourth and we have x cubed down here, we can't go any further. So whenever the degree of what's left is less than the degree of the divisor, you know you're done. You're down to the remainder. So now we're ready to go to the answer here. Okay, it's the 3x squared plus 4x minus 3, what we got from the top up here, then plus a remainder over our divisor. So plus negative 25x plus 9 over x squared minus 3x plus 5. Okay, so if you want to check, you can check the result of a division problem by multiplying the quotient by the divisor and adding the remainder. The result should be the dividend, which you divided into. So we can check this by multiplying 3x squared plus 4x minus 3. That was the quotient, times x squared minus 3x plus 5, that's the divisor, and then adding the remainder. And if we do that, here we're showing multiplying the 3x squared by everything in the second factor here, plus 4x times everything in the second factor, minus 3 times everything in the second factor, and then adding, right here, we're just adding the remainder. And there's everything all expanded out, and when you clean everything up, you get back to your original dividend. 3x to the fourth minus 5x cubed plus 4x minus 6. All right, let's do another example. We're going to divide x cubed plus 5x squared minus 7x plus 2 by x minus 2. All right, so here we have it written in our format. So remember, the very first thing we're going to do is do the x cubed divided by x to get x squared. And that's going to be our first term in our quotient. And then we're going to multiply the divisor, the x minus 2, by the x squared. So that gives us x cubed minus 2x squared. Okay, remember, after we multiply, we subtract. Okay, x cubed minus x cubed is 0. 5x squared minus negative 2x squared is 5x squared plus 2x squared, which is 7x squared. And we bring down the next term, so minus 7x. So now what are we going to do? We're going to repeat that process. We're going to take this 7x squared and divide by x, and that is going to give us 7x. And that's going to be our next term in our quotient. Okay, so now we multiply the divisor by 7x. And so that's going to give us 7x squared minus 14x. So after we multiply, remember, we subtract. So 7x squared minus 7x squared is 0. Negative 7x minus negative 14x, so that's negative 7x plus 14x gives us positive 7x. And then we bring down the next term, which happens to be the last term, so plus 2. All right, we're kind of getting to a point where we look and go, all right, do we keep going? This is my remainder. Well, if you look, you have a tie right now. What we have right here has a degree of 1. Our divisor has a degree of 1, so we can keep going, but this is going to be our last step. Whenever you get a tie like that, you know, okay, this is the last time we're going to go through our little process. So we're going to do 7x divided by x, and that's going to give us 7. And so we're going to have a plus 7 up here. And now we multiply the divisor by the 7. So that gives us 7x minus 14. So what do we do now? That's right, we subtract. And that's going to give us our remainder. So 7x minus 7x is 0. 2 minus negative 14, that's the same as 2 plus 14, gives us 16. A constant like this has a degree of 0. And then a plain x has a degree of 1. So we are to the point where we have a smaller degree than what we started with. So for sure, this is our remainder. And so our answer is going to be x squared plus 7x plus 16 over x minus 2. Okay, so some of y'all are probably thinking, oh my goodness, there has to be an easier way. Well, there is when we have a problem like this, when we're dividing by a nice little binomial like x minus 2. We call that a linear divisor, okay, because it's just a little binomial and it has a degree of 1. Whenever you are dividing by a linear divisor of the form x minus k, so if we have x plus something, we're going to write x minus negative. We have to write it as x minus something. Synthetic division can be used. Okay, so we're going to use synthetic division. It's exactly like synthetic substitution. Okay, it's just you start off with something in the form of x plus 3, and you have to kind of work to figure out what your value is going to be that goes kind of up to the left. Okay, now remember, for synthetic substitution, you took of the polynomial, you took all the coefficients. If there was a missing degree, you filled in with 0. So we've got 2 and then 1 and then negative 8 and then 5. Now remember, this is in the form x minus k. So we have to think of this as x minus negative k. So, not x minus negative k. We have to think of this as x minus negative 3, because our k value is negative 3. So we put negative 3 up here. Okay. Now remember, the first thing you do is you take the first coefficient and boom, you just drop it down here. All right, so we drop that down here. And then we do 2 times negative 3 is negative 6. And then we add down the column. 1 plus negative 6 is negative 5. Negative 5 times negative 3 is 15. Negative 8 plus 15 is 7. 7 times negative 3 is negative 21. 5 plus negative 21 is negative 16. All right, and believe it or not, we've got our quotient and we've got our remainder. The quotient polynomial is always going to be 1 degree less than the original polynomial whenever you're doing synthetic division, because we're always dividing by a linear divisor. So that's why that always works out. So I know that that 2 is going to be for an x squared term. Because we had x cubed, we go down 1 degree, it's going to be x squared. So we're going to have 2x squared minus 5x plus 7. And then you could write plus negative 16 over x plus 3, but since it's just a plain number that's in our numerator here, it's really better form to write minus 16 over x plus 3. So that's why we write it like that. And so that's our answer. Much faster. So most of the time, unless I'm telling you have to use long division, when you have just a linear divisor, you're probably going to want to pick synthetic division. Okay, guys, that's it for video 1. I know you're probably thinking, okay, we're supposed to be using theorems to be able to factor. We're going to get to that in video 2. Don't worry. I'll see you in a few in video 2.